Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about how we can model this exponential relationship into LTspice, ID versus VGS. VGS is our variable and I0 and V threshold are just some constant values, but this is an exponential relationship. I'm going to give you an idea that you can apply it to any kind of mathematical relationships that you want to model in LTspice. Okay? But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell so whenever I upload a new video, you'll be aware of it. Let's jump into it. This is our LTspice, and here I use P for placement. When I want to place something into LTspice, the hotkeys in LTspice is really a game changer for you guys to become a professional electronic designer. I'm going to use BI2, arbitrary behavioral current source, to have a source current which is dependent on which we can define a function for that matter. Okay, I is equal to f of something, function of something. Now this something could be any mathematical relationship that I want to add into this current source. So here I define the f of for example f of x. Now I'm going to define f of x into a function. I use dot for writing command, not comment, LTspice directive. I use some keywords to define my function relating to this f of x. So dot func, a hotkey for defining a function. What is our function? Function is f of x, that which is going to I'm going to define it. What is it? It's I0 times exponential VGS minus V threshold. Now I'm going to define these different variables dot param for introducing some constant. For example, I0 equals to 30 milliamp, V threshold equals to, I don't know, maybe 1 volt. And how about the VGS? VGS is something that we had to define it as a variable which is changing over a time. For example, VGS is had to change from 0 to, I don't know, maybe 5 volt with a step of 0.1. In order to define this VGS, you had to use .dc as a command. Okay, these are really important in LTspice. So here you can see our function, our variables, our constant into this function. And in order to plot something, it is better to, as a circuit theory, for circuit theory, use a resistor in parallel with this current source, and I don't know, maybe 1 ohm will do the job. And always have a ground in your circuit. Don't forget that you have to have a ground. Now I'm going to plot this I, and if the exponential function is not very clear, we can change, for example, I0 or V threshold as our constant to just for the sake of simplicity and clarify our result. Okay, and you can hit S to move this function around. These really hotkeys are really helpful for you. So run the simulation, delete the previous ones. So here, unknown symbol VGS. So this couldn't find my VGS. Here I define this VGS, but it seems to have a problem with that. Let me, as you can see, when I right click here, it says VGS is something like this. So VGS is a voltage. Maybe it had to be on, I had to define it as V of VGS. maybe, I don't know. Unknown circuit node VGS requested in behavioral source. Okay. Now I get it. VGS is a voltage which is variable, so I had to define it somewhere into my circuit, so I had to put a voltage source for that, and this is our VGS actually, and this is our node as a VGS, and I think it is better to define this variation for VGS in here, not there. So I'm going to use PWL in a time 0 equals to 0. When times goes, for example, in after 10 millisecond, we have 5. So this is something like a ramp function for VGS. And now I had to delete this in here. It had to be a node, and maybe 10 milliseconds will do the job for our simulation. Now we can see the result. Okay, I just plot IB, but not versus VGS. By default, the horizontal axis is just time. In order to change it, because we want to see how I changes versus VGS. Okay, this is something that we're looking for. You just right click on the time axis and write V of VGS as your variable. And as you can see here, it's our VGS, which is different from 0 volt to 5 volt, and this is our exponential function I, which we define it. And you can for example, somehow change these variables if you want. For example, you can change V threshold to 2 volt, or maybe I0 from 30 milli to 20 milli. It's completely up to you, and you can see a little change into this function, into this plot. Okay, now with that being the case, you can use any functions in here. You can define it, or you can place BV in here. BV is a voltage which is a function of something else. Okay, function of f of y, f of anything. So BI, BV, you can use this to define your functions, and be careful if there is a dependency. For example, here I is dependent on VGS. VGS had to be a voltage node. We cannot define it as .dc in here, as you can see. Okay, I hope you learned a lot. This is a walkthrough video. I want you to be somehow my assistants in here, and we are learning this together. Okay, and you can apply this method in order to implement any mathematical relationships, because sometimes you just want to have a simple model for your design, and after that maybe you put your real model, but sometimes the real model, the real relationship is not clear, it's not crystal clear, so you had to model it in this behavioral method. Okay guys, I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.